All right, can people see my RStudio Cloud environment? Give me some thumbs up, some reactions. Okay, I see some thumbs, some claps. All right, I got a party in here. Cool, so I'm just gonna make sure that I can see another chat window. There it is. All right, so just as a quick overview of what we did yesterday, just getting familiar with the environment. So we started with just familiarizing ourselves with the RStudio layout. Just as a reminder, so on the left side is where a lot of the code and the coding is going to be happening. Oh yeah, Lee made an important announcement. If you would prefer not to be in the recording, you can turn off your video and change your name to an alias throughout the class. I will say that it is helpful for me to see at least 5 or so videos just to catch people's reactions, see what they're doing. I appreciate those who do have their video on. It's very helpful for me. But for everyone else, it's okay if you don't have your video on. Okay, going back to the explanation. So really quickly, as I was saying, the coding is going to be happening on the left side. On the top left-hand corner, I currently have part 1 open, just like we had going on yesterday. One second. And so these files, the file that we're working with right now is called an R source file. And you'll see that the extension on that file is .r. And basically, this is how RStudio knows to read this as an R file. We learned that if you use these pound signs, you can include notes into the code without confusing the software in terms of figuring out what you're trying to tell it. Yeah, so that's that for our source files. At the bottom, we have the console. This is where the code is actually going to be run. So if we are running code within the R source file, we can highlight it and then hit Control Return, or just click on this Run button and it will run. The way to know if you're creating objects like this, objects you can think of as variables that you can work with, or different things that you can work with in our tables and such. These will show up in the global environment in the top right-hand corner. And as you change objects or change variables using different filtering or selecting commands, you should be able to see those changes in the number of observations and variables here. For example, we did a step where we selected certain columns from the state pop column or from the state pop object or variable. And if I run that, if we look at this global environment section here where it says 52 observations and 25 variables, once I do that selecting step where I select these 3 columns, state abbreviation, and pop millions, we see that the observations doesn't change, 52 observations, but the number of variables does change to 3 variables because we've selected the variables that we're going to want to work with later on. So if you go to the section day 2.1, more data wrangling with dplyr, I'm at around line 500. I've retyped the code just so that folks can get and import all of the necessary data for this particular section. Lastly, we have the bottom right-hand corner, which we used for a couple of things. We used it to move around our working directory. So that's the folder that we are currently working in. You can use this little gear symbol more to set as working directory or go to your working directory. These are useful tools to make sure that you know that R knows where to run the code because it's kind of functions within a particular folder. The last thing, we covered a couple other things, including the packages. So you'll know that if packages are loaded by seeing this little check mark next to the package that we're running. And in the help tab is where you can search for information about the syntax and which is basically the way that you write out specific commands in R, and you can search the commands using this search bar. We're going to get some practice using that today. And yeah, so with that, oh, in addition, I mentioned the cheat sheets, which if anyone got a chance to review them between yesterday's session and today, it might still be a little bit of a mystery as to how they work. Hopefully with a little bit more experience using dplyr and ggplot, you'll get a little bit more of a sense of how these cheat sheets can be used. With that, I want to open it for any questions before we get started. And if you don't have questions, throw up a thumbs up and we can get started with day 2.1. I'm getting some audio from someone. If you can mute your mic, that would be awesome.
Somebody in the questions asked, is R 0 or 1 indexed language?
R is a 1 index language. I feel like that question comes up like almost every time, especially for people who know Python, because Python is a 0 index language. And that just basically means lists start at 0 and not at 1. The last thing that I wanted to mention, sorry, Jamie, were you going to say something?
I was just saying, if you use databases, sometimes you get used to the index 0.
Yeah, totally. Nice. Thanks, Paul, for asking the question. The last thing I wanted to mention was there were some questions about vectors. So we're not going to really cover vectors in depth in this particular session, mostly because we're working with tables that we're importing. Vectors in R, just in its simplest form, are just lists. So a vector is a list, and there's different ways to create vectors in R. But we're not going to like cover that in detail right now. There is a link that I sent in an email this morning, and I'll send it again at the end of the session with a little bit more about vectors and functions in R. Hopefully that can clear up some of the questions around that. But for the folks in 275 and 199, they're not going to be quizzed on knowing these things. And yeah, so if I use the term vector, just think of it as me using the term list. All right, so I had some thumbs up earlier, but I didn't see a whole lot. Are people down for me to move on to day 2.1? You ready for some data wrangling? All right, seeing more reactions. Okay, great, awesome. Thank you all so much for the reactions. I appreciate it. Okay, so let's just dive right into it then. So I use the term data wrangling a lot, mostly because I think wrangling is an awesome word. But at the core of it, data wrangling describes the process of reshaping data into forms that are more readily usable for visualization. So as I had mentioned earlier, there's certain packages in R that are a little temperamental. They can ask for very specific data structures in order to execute their functions, and so, or execute like their tasks. And so doing some level of data wrangling is very useful because it helps clean your data, helps organize it in a way that that is more easily interpretable. And we can see some examples of that in our state pop table, where we had this really wide table with 52 observations and 25 variables, and we trimmed it down to 3 variables. We'll get a chance to simplify our COVID data table as well. Another useful thing about these data wrangling tools, and in particular, we're going to be using dplyr and tidyr. These are the libraries. We'll go into the commands in a little bit. But what's useful about these is using these tools, you can also calculate new variables very quickly, and you can merge tables very efficiently. You can pivot tables very efficiently. So it's a really useful way of doing things that you would do in Excel, but it does it even faster. If you have nothing in the global environment, then you can just highlight these lines of code and run them, and it should give you all of the important data for our session today. So you can just highlight that and click run, and it should run if you were in the correct working directory. So once we have that loaded, the next step that we're going to do for this process is we're going to merge some tables together. And so you can imagine a situation where you have information on two sets of tables that you want to put together, but they're of different sizes. So so in this case, we're looking at our COVID data table, which has 11,000 observations. And it has all this information about states. And what we want to do is we want to be able to calculate the number of cases per million. So we don't want just the number of positive cases. We want the number of cases per million in the state. But the COVID data table doesn't have any information about the state population. So we can't just like very quickly calculate the cases per million value for all 11,000 observations in this table. So what we're going to want to do is we're going to want to merge these two tables so that we can create a way to more easily calculate this step. And we'll see how this works in just a second. The way that we're going to do this is we're going to use the full join command. We're going to use the left join command. Ooh, that's a typo on my bad. And so I have an example of how this is going to work on around line 529. So I see a question in the chat. So if someone has an error, they could not find the function select. This is probably because the package dplyr was not loaded. And so you're going to want to run this library dplyr. I just typed it into the chat. You're going to want to run that, and it should run. So when in this command, we can look up what this functionality is by going into the search term left join. So when I was learning how to do this, and when I was originally trying to merge these two tables, all I really did in order to figure out what command I needed to use was I just looked in Google how to merge tables in R. And I found a whole bunch of answers and eventually came across, after doing a little bit of digging, came across one that looked particularly good or made sense to me. And so what we're doing using this left join command, it's a part of a family of commands called mutate joins built in dplyr. So to kind of unpack how to read this documentation, at the very top, it'll tell you what the kind of classification of the command is, and then it'll tell you what package it's a part of. So you can see that this one is dplyr. There's a whole bunch of different versions of this command. There's inner join, left join, right join, full join. And it tells you a little bit of information about how they work. And we can talk about that just a second. In this case, we're going to be using left join. And so we're going to want all of the rows in, well, let's take a look at the usage first, because this might be helpful. For the inner join command, they all have similar usage. The first thing that you do is you tell it the first data frame that you want it to incorporate as X, the second data frame that you want to incorporate as Y, and the by is you tell it what is the column that is common between these two. So what's the column that needs to be matched between these two tables. You can find a little bit more information about the usage, the different arguments by scrolling down and looking at the arguments area. So it'll tell you XY is a pair of data frames or data frame extensions that can be put together. By is a character vector of variables to join by. So when we look back at the code that I have written here, we remember that this arrow is the assignment operator. So it's a way of assigning new objects or creating new variables. And we're creating a new variable called COVID state data. We're taking the state pop table and we're merging it with the COVID data table. And we're telling it that it needs to merge it by this identical set of columns. And so when we run that command, so we can highlight and click run or control return, we can see that our COVID state data looks a little bit different than our COVID data, and it looks different than the state pop data. We can see that in the COVID state data, there's 2 additional variables, and we can see that there are fewer observations. So this tells me that it has done either some trimming of the data, but also has added some columns. So we can take a look at it and see what are the changes that have been made. So someone else has a could not find function select. Be sure that you have library, or that you have loaded dplyr. You can check if the dplyr package is loaded by going under the packages area and then scrolling to dplyr and then hitting that check mark.
Does this left join only work if you have data tables with like identical columns at some point?
Yeah, so, well, any of the join commands will only work if you have some identical column. The other way to join like variables or tables is using the data frame command, which we used yesterday, or using the select command from dplyr by picking columns. Does that answer your question?
Yeah, thank you.
Okay, awesome. Were people able to get this to work on their machines, like create the COVID state data table and see something similar?
When I tried and I got an error, so then when I went to library dippler, I tried to rerun the library dippler, or I should probably go to or install the I'm trying to install dippler again. And
if you're in the same session that you were using yesterday, you shouldn't have to reinstall it. You might want to check the spelling of dplyr, or just go into your packages tab like I have shown here, and then just make sure that that check mark is there.
okay.
The other ones that we're going to be using today, if people want to just get this out of the way, is we're going to be using ggplot. And so you can make sure that there's a check mark there as well. And we're going to be using lubridate. So you're going to want to make sure that there's a check mark there as well.
So if it's working, or if I have all the programs installed or the packages installed and I'm still not able to run the code, then what should I do?
You want to check if you are in the correct working directory.
Okay.
So make sure that you're in the correct folder. So if you click on the files tab, you should see part 1, like all the stuff that I have here, something similar. We have another question. We have another question.
Why
not?
Oh, okay.
I'm looking at a question in the chat. So the name of the columns does not need to be the same. So the by section is how you tell it what columns are the same. So they don't need to be the same. Sorry, I didn't mean to interrupt the person who was just asking a question.
Yeah, I just had the question of like that construct of like, what does the C mean there? Is that column?
Oh, yeah. So this is actually a way to create a list. So C just tells it that there are 2 items for it to consider, or C just says that there are multiple items that it needs to consider. In this case, there are 2 that need to be considered by this term by.
Okay.
Lee or Jamie, would you have like another way of describing how C works? It's a term that just means concatenate.
Okay.
And that's just to create a series of items. So I can you like create a new variable and test. I'm gonna go see this is a list. And if I run that, I create a value or another list here. It calls it value here for now, and it just creates a list of these 4 words. We could do this with numbers too.
Okay. Got it.
Yeah, that's a clear explanation, Ibrahim.
Awesome.
For C.
So let's take a few minutes to just kind of explore some of the questions here below. So I've started answering this question, how the tables merge together. But if folks want to, they can test out what happens if you use other types of joins. You might get a different number of observations or variables. So if you've tested one of these out, just drop into the chat how many observations or variables that you see. One thing that I'll say, because I happen to know these data sets particularly well, the reason why we have fewer observations in the COVID state data with the code that we currently ran is that the COVID data itself includes information about a number of territories like American Samoa, Guam, that are not included in the state population list. And so this is one of the reasons why we would see fewer observations as a result of merging the tables. So these kinds of like tricks or issues, sorry, my screen is going crazy. These kinds of kind of tricks or issues that you run into is how you can kind of like notice like what data is included or excluded in your analysis. Kind of paying attention to this like number of observations and variables, as I had mentioned, is really, really useful in knowing what's happening to your data.
Everything is working on my end. I'm so happy.
That's great. So did anyone try out right join or full join? Let's see, right, let's make a new test one. COVID data test. Right, join. And then we're gonna use the COVID data. Which table do we use first? State pop. For people who are seeing a slightly different order of, so for the person who's seeing like nothing but AL in the beginning, they might need to scroll down to see the other states. R will kind of automatically sort the data sometimes, and it could be that what am I saying? It could be that that the data is just sorted in a particular way. COVID data by equals. I'm just gonna copy and paste this to spare some time. And run it. Oops. So you could see that I got an error, and it's because I have way too many quotation marks here. So like I said, typos are the most common errors. So our test variable has a different number of observations and variables. So I'm gonna start looking at the questions. So, so good question. So we had one person ask, how do you know which merge is the right merge? I had to test out like 3 different merges to make sure that, that I included all the right things. that just testing out different commands for merging tables is one way of just seeing like, and kind of reviewing the data table is a useful way of taking a look at that. So if you do right join, which is the kind of the other way of, I guess the right version of this table merge. The way that it functions is, again, looking at the help area, we can see that they function based on this. So in left join, all the rows in X were included. So that's all of the states that were in the state pop variable. In right join, it's all the rows in Y were included. So that's all the rows in the COVID data table. That's why the COVID data test has the same number of observations as the COVID data table. And the way that you figure out like what table is what is by just looking at the overall usage. So you can see that X is listed first, Y is listed next. And just by following kind of like all rows in X, all rows in Y, that'll tell you which one is like the left or the right table. Do we have any other questions, or are people down to move on to using pipes and dplyr?
What's the difference between right join and full join? Because they seem like they would be the same thing if we're just adding all the columns in Y. Shouldn't we also be adding all the rows, or is it just going to add the character?
So just what I would recommend is just testing it out and seeing what you get. Sometimes you just kind of have to test out the commands and see how they work. Sometimes the left join or right join might not do like exactly what you're hoping for them to do. Like I've run into that before where I just like trim the data table too much. Full join is a little bit more inclusive, so it will include all of the rows in X and in Y, even if like one or both of the tables does not have those variables. It's just a really inclusive way of merging tables.
I think also full join, it's or instead of and. It's all the rows in X or Y, if that makes any sense.
Yeah, so that would mean it's inclusive. So let's take a look. So someone just asked if it's adding data while merging the tables. So in our COVID state data table that we created, we are actually adding data. So what we did was we wanted to make sure that we could have a record of the population in millions for each state. And you'll see that the population in millions was added kind of in a repeated manner for everything associated for each state. So in this case, we're seeing Alabama is listed first. It's now the data is now sorted alphabetically and by date. So there's a ton of data in here. So I don't want to scroll too far. But then you will see that Alaska is listed next. So we are actually kind of filling in gaps or adding data when we're merging tables.
Ibrahim, if you look at state pop and then COVID data, yeah, it seems like it just kind of put the state pop information in front of COVID data and then skipped one and started at date. Why did it not include state?
Because so we I think it's because of the way that it was listed. So it basically will take the first since this is the common column, state abbreviation and that state the state as it was in COVID data. So we'll see here the term state was just the abbreviation. And so this column state was replaced with, oops. was replaced with state abbreviation, and a new column state was created with the state name written out in full. This did not exist before because it only exists in state pop. And then the population in millions was also added.
So it's almost like you replace that column with all of state pop and then moved everything to the right in COVID data?
Yes. And it's the way, because we listed state as first, right? So that's X, and then we listed Y as next. So it kind of like this table first, this table next, and then it kind of shifts over and fills in any of the details necessary.
Thanks.
Yeah, of course. Yes, so the order that they're listed in the command XY does dictate the order that they are merged, X to the left of Y. And you're gonna wanna pay attention to like what X and what Y means based on the syntax that you can find in the help area, or like usage that is described. Okay, so let's go. So I appreciate all the questions. Let's move on to using pipes and dplyr. I wanna get through this particular section because that'll take us closer to data visualization, which is what I want to spend the bulk of the session on today. For using pipes in dplyr, so a pipe is just this symbol here. It's a percent kind of, is that a greater than symbol? Percent greater than percent. And so the way that this works is it allows you to channel multiple commands used in dplyr in one step. So if we were to, so I have an example in around line 560 or so. This code is not actually going to work, so you can't run it. It's not going to do anything for you. But this is an example of how using pipes could work. So you take an old data frame, so an original data frame that you're working with. So in this case, it could be COVID state data for us. We'll see how to use that in a little bit. And then we're going to use the assignment operator to create a new data frame. We can also overwrite a data frame by using this syntax like this. So we just, instead of using new data frame, we use old data frame, but we don't need to do that. And then what you're gonna do is you can type in this symbol here, a pipe for dplyr, and then you can run any number of commands that are used in dplyr. And I just have a few examples that could be useful here. So for example, we've already seen the select command. And since we list the data frame first, this is a dplyr package. Since we list the data frame first, we don't need to tell every single command what data frame to look at. We could just tell it directly the columns to work with. So we can just say select column 1, column 2, and column 3, which will select columns from our old data frame. We can then group by columns, which is really useful for calculating or filtering data sets. And this allows us to group by information contained in column 3 in this particular example. We can then use something like the mutate command, which will create a new column by giving it like a simple calculation. In this particular example, we are creating a column 4, which is based on column 2 times 2. And then finally, we can filter, which is another thing that we've seen before, by using, in this case, this exclamation point equals means anything not equal to, or like the complement of. And basically this means removing NA values, so like empty values for anything in column 1. So this is just some example syntax, and we can see how it functions in practice in our example below. So if we want to calculate the number of COVID cases per million for residents in every state in the US, You'll notice that when we merged in the table above, the state population in millions is now aligned with the number of positive COVID-19 cases. So let's quickly take a look at COVID state data to see how that actually works. So we now see that the population in millions is now listed, and the positive cases are also listed, and this goes for all 11,000 or 10,000 or so observations. And what we're going to do is we're going to use the mutate function to create a new column that basically divides the number of positive cases by population in millions so that we get this number of cases per million. We have a really good question in the chat saying, when you create a new column by mutate, will it just be called column 4 on the header? Can you give it a specific name? So yes, you can give it a specific name. Looking at the example before, in this case, we would create a new column named column 4. But I could also just name the column, I don't know, we're gonna call it Panda because I'm a fan of Panda. So now this column is just called Panda. So that's not a really useful name. As I had mentioned before, a useful way of naming things is by giving it an informative but short name. The group by command is useful for grouping terms if you're doing like different kind of statistics on there, or if you're filtering things in a variety of ways. I'm trying to think if we have some clear examples of how it's used. But I can try to put together some examples for how it's used later. We're gonna not worry about, at least in terms of functionality, we're not gonna use group by like immediately. But it is a term that, or a function that I've used in the past to do either calculations or statistics on different things. I don't know if Lee or Jamie, if you have experience like when you would use group by. I mean, I feel like I use it a lot, but we don't necessarily use it
in SQL. You'll want to group, it's like like you said, statistical. You'll want to group by political party or group by demographic.
Right.
Somebody asked about the pipe function. Is that just for dplayer? I thought it was also the whole tidy data package.
Yeah, so the pipes work in the whole tidy data package. So that includes dplyr and any command in tidy, like that uses like the tidy from the tidyr root. So question, what happens when NA is removed? What is removed? Is the shape of the matrix altered or are particular columns removed? So in the case of the filter command, we are only removing rows. We are not removing columns. But for example, in the COVID data test, which merged which included all of the data for what am I saying? In the COVID data table, we'll see that, let's go down to, let me see if I can find an example. Might take me a second, but I think I can have a pretty concrete example for this. Okay. Maybe CIS. I'm looking for data from American Samoa. Arkansas. Basically, when you merge tables, certain oh my goodness, this is just very temperamental. So when you merge data tables, there is a chance that that certain data points do not exist for certain for like one of the tables that you're merging. And if data points don't exist, it will automatically introduce an NA, which is like an empty data, like an empty like piece of your variable, and filtering out places where there's NAs will can make it easier to do calculations and prevent kind of downstream errors. So for the indentation, when you're writing the with regard to the pipes, so I'm just going to write another. I'm just going to write another test example. So test 2, and then we write our pipe. So if we hit return from this, it will automatically include the indentation. So this is just a way to make the code a little bit easier to read when you kind of see what commands are all strung together. And to answer Christina's questions, group by does sort the data by group. All right, so we can see in an example here that what I'm doing here is I'm taking the COVID state data and I'm using the mutate command, which we had talked about earlier, to create a new column. And I'm creating a column called CPM, or cases per million. And the way that I'm calculating that is that I'm taking the positive cases and I'm dividing them by population in millions. And I'm assigning that to a new object or new data frame called cases per million. And I'm filtering out anywhere where population in millions is NA or is an empty variable, because we can't divide positive by nothing. So if there's an NA in population in millions, it might give us an error. So we're just going to filter that out in this step. So if we run that, we can see, yes, it removes entire rows that contain NA. Filter will do that if you tell it where the spot is with NA. In this case, we're looking at the column population in millions with NA. So if we look at our cases per million variable, we can see that it has the same number of observations as COVID state data, but it has, instead of 56 variables, it has 57 variables because it created a new column called cases per million. And if we look at the table, we're not going to be able to see it, mostly because we have a very wide table. We'll have to scroll all the way to the right, but even then, it'll only show us 50 columns at a time. So if we go to the next, so if we kind of move the table over, we can see that at the very far end of the table, this new column is calculated cases per million. And so in that sense, using this command, we did 10,850 calculations of cases per million, basically instantaneously.
So how did you get to that? How did you move it over again?
Oh, yeah, I'll show that once more time. Cases per million. So in this columns, you'll see that it shows like 1 to 50. There's these little arrows over here. If you just click on these arrows, it'll shift it over. In this case, we have 57 columns, so it only shifts it over 8. And then if we scroll all the way to the right, we can see those cases per million. We have a good question. How do we move the order of the columns? I think there's ways to move columns around, but I generally use the select function to just pick the columns that I want to use for specific analyses, which will like clean up the data to make it a little bit easier for me to visualize. Yeah, we'll see an example when I start picking specific columns, how we can just kind of clean this data up. This is the data cleaning portion of it. I think there was like a really useful graphic that's often shared in Data Science Center intro to R workshops, where basically they show that the amount of time you spend like using R doing computation, like the vast majority of it is in this data cleaning step, where you're calculating new columns, cleaning up the data set so that it's easier to visualize. Because analyses, as I mentioned, this calculation that we did took just literally an instant. How do we remove entire columns? So one of the nice things about R being like a non-destructive editor is that you can keep columns in one data frame just to kind of like have just in case, and then you can select columns and create new data frames. So you don't necessarily need to remove columns. Lee and Jamie, do you know if there is a particular command to remove the column from a data frame?
I do. I wrote that down somewhere, so I'm trying to find it.
I don't remember, so I'd be out there Googling right now on Stack Overflow.
Oh, we have a really awesome question. How do we clean up our environment by removing data that we don't want anymore? So yeah, there's a whole bunch of stuff in here now that I really don't want anymore either. So we can use the rm command. So I can type it into, well, it doesn't matter where I type it in, rm, and I can remove test, for example, and that'll remove the values that I have here. Rm test, oops, test 2, remove that too. I'm just gonna clean things up so that it's a little easier to read. I don't want that either. Another way to just completely wipe clear the entire environment, which I don't recommend anyone does right now, there's this little broom, which will clean up the entire environment. So it'll remove all of the objects or variables that you've created in your analysis. And that can be really useful if you're doing a really long like coding process and you've created a lot of variables. You don't know you don't know which variable to remove necessarily. You can just clear the whole thing and then rerun your code to see if it still works. That's a good way to check the reproducibility of your analysis as well. So we've used this filter command, and we use this particular relational operator, which is like everything but NA basically, or remove things that are not NA. But there are a variety of other relational operators used in R. And we used some earlier. Can folks just drop into the chat other relational operators that can be used for filtering? A hint is you can find the answer on the dplyr cheat sheet, or think of other ways that you could just filter information, numbers or even text. Yep, less than or greater than, those are really useful relational operators. You can also throw in an equal sign after that and make it less than or equal to, greater than or equal to. The double equals is a test for equivalency. That's a really useful one as well. Yep, the exclamation point equals, which is what we used for the everything but. I think there's a couple more listed in the dplyr one. I'm trying to think of, I think there's, and I think might work as well. Yeah, so these are all kind of useful ways of filtering different things in using this particular command. So thanks everyone for those suggestions. So I'll just, people can type it into their code as notes. So I have a challenge. So I want to say we've hit just about the hour. Let's take a quick break before we go into plotting with ggplot. But during this break, for anyone who wants to experiment with this challenge here, if we wanted to plot to show only data from states once they reach a threshold of 1 CPM, cases per million, how would we rewrite the filter command to remove all cases per million values below 1? We're going to use the relational operators from before, and we're going to use a similar syntax as this right here. So we can even just copy and paste this code down here and then just make some edits if we want to avoid having some typos. But what I'm going to do is let's get that challenge started as an option, and then let's regroup at 10:10 to go over the answer to this question and carry on from there. So break starts now. Let's regroup at 10:10.
Wait, Ibrahim, where's the challenge?
The challenge is approximately on 580, line 580.
Oh,
it says,
okay.
Yeah. What if we wanted to, oops, I have all kinds of grammar errors. I apologize for that. What if we wanted to plot, what if we wanted our plot to only show data from states once they reach a threshold of 1 case per million? How would we rewrite the filter command to remove all case per million values below 1? I'm going to stick around during the break to answer any additional questions.
I have a lot of questions. Can I share my screen, please?
Let's save the screen sharing until after the session, because we have a limited time during break and there's a lot of questions. But if you can type them into the Q&A document, then that could be one way of us to look at that. I have another question that came into the chat that I'm going to try to answer first. So, the question is, okay, so there's a question about the order in which commands are given. So in this case, maybe in this example, how did I know to like do it in this particular order or in this particular order? So it's gonna depend on like what exactly you're doing. The order does actually matter. You don't want to filter out. So let's say, for example, in this case, you want to perform a calculation, and then you want to remove any place where the calculation like failed or like gave you a value that's not useful to you. In that case, you're going to want to do the filter command after you create that column or perform that calculation. And so like in that sense, the order does matter, but it's the order of the commands is going to depend on what exactly you're doing. But I would say generally the creation of new columns happens before any filtering steps in that case. I'm not sure, so I see the question, can you define verb, please? I'm not sure what you're referring to.
I was on mute, sorry. It's for around 607 for pipes or operators that can be used to string together verbs in Dipler.
Oh, so verbs are going to be these commands here: mutate, filter, select. I think I took that that language from some other way of describing dplyr.
Okay, I get it then. Okay.
I have a question about the code that created CPM.
Yes.
I didn't get CPM. I didn't get an error either. If I scroll all the way to the end, it says hash, and there's just a bunch of like alphanumeric stuff.
Yeah, so let's scroll all the way to the end. I think you probably see something similar to me.
Oh, yeah.
So if we go to this little columns area, so right now we're only looking at columns 1 through 50, but we have 57 variables. So we're gonna have to push this little arrow button and then scroll all the way again to the right, and then that's where CPM is gonna be.
So
it's just added to the end of the table.
So if I scroll all the way, oh yeah, okay, there it is. Got it.
Yeah.
Thank you.
Yeah.
But when I ran the function, I didn't get a new tab in the area, and I tried looking through the scrolling to the right of the COVID state data, and I couldn't find it.
Well, that's because it should be in the cases per million data. There's a new table that we created, and you're going to have to click on that in your global environment and in order to get the tab to open. It's not going to automatically open.
Oh, okay. Thank you. So then, I'm having trouble because there's all of these columns that have characters X, X.1, X.2, X.3, and all of the factors are just empty tables, and I'm having a hard time trying to delete it because when I put try to use like a filter function, it doesn't remove them.
There is a chance that the select command from the beginning and state pop did not run. So you're going to want to rerun this right here, select state pop, this command here around, I don't know, I think it's line 514. And then rejoin the table. And that should clean up all of those empty X variables.
Okay, thank you.
I'm gonna myself take a quick break and be right back right around 10:10. So I'm gonna stop sharing for just a little bit. All right. Get back into it. So the last thing that we left off on was trying to create a plot where we only show data from states once they reach a threshold of 1 case per million. What I did, I initially just copy and pasted the code from last time, but this isn't actually going to work specifically for us as it is. Oops, I'm not sharing my screen yet. Of course, share screen. Thank you for the reminder. Can folks see my screen now? Throw up a thumbs up or a nod. You could see it. Okay, I see a thumb. Okay, so I left off, like I was saying, was trying to filter so states reach a threshold of 1 case per million. I just copy and paste just for the simplicity of it. I'm gonna create a new variable just because we're just doing an example. So I'm just gonna call this case per million test. I'm gonna pull, we can run a similar set of commands directly from COVID state data. So the first thing that we're gonna do is we're gonna create that case per million column. We can keep the filter population in millions a step here. And we're gonna just create a new pipe. And we're gonna do a second filter command, filter. And then we can put CPM, because we want to filter on the case per million column, which we now know exists. And we're going to say anything, we want CPM greater than 1. And so we're taking the COVID state data with about 10,850 observations. And we're just going to run this. We know that without this filtering step, that we're going to create 57 variables and we're going to have 10,850 observations. But with this filtering step, let's see what happens. So you know that it ran if you're not getting any error in the console. You can see that a new object was created here. Let's see if I can make this a little bit bigger. You can see the names a little bit more fully by going on that line divider and dragging it over. And in case per million test, we have fewer observations. We have 10,487 observations instead of 10,850 observations. That means there were somewhere around 350, 370 observations that were less than 1 case per million, and those have been removed in this test table. So that is where we both can calculate in one step, calculate the number of cases per million, and also then filter on the new variable that was calculated. So that's an example where the order does matter here, because if we tried to filter on cases per million before, it would not know what to do. The error that you might get would be cases per million does not exist or something like that, because it hasn't been calculated yet. Does that make sense? Do we have
Ibrahim, the percent sign, 2% sign just tells you like do the next line after that kind of?
Exactly, yeah. Yeah, so the other word that you'll commonly see used for that is a pipe. So it's just like a pipe from one command to the next command.
And is that so you don't have to write the cases per million test everything over and over again?
Exactly. So usually for any dplyr command, it'll ask for the data frame that you're working with and then what you want it to do. So like if I were to just run this mutate command here, I would need, like if, let's see, let me see if this will work. If I just highlight this line right here with nothing else around it and I hit run, it'll try to just run this mutate thing. And it says object positive not found because it doesn't know what data frame to work with. And so in order to, so you'll have to give it like an actual data frame. So in this case, we could say COVID state data, comma. So that's the data frame that it's working with and the command that you want it to execute. And then if we run just that code itself, I'm not going to do that right now because it's going to list 10,000 things, or it's going to try to list 10,000 things on my console. That's how like normal dplyr commands are written. So the pipe is really nice because it allows you to do multiple things with one table all in one step. I hope that makes sense. Are folks ready to move on to plotting with ggplot? Throw up a thumbs up or a reaction for me to know. Got some thumbs. Awesome. Oh, great, great, great. Really, really, really appreciate y'all's responsiveness here. Okay, so for those of you who have heard peripherally about R or have heard anything about plotting in R, you might have heard the term ggplot. And the GG and ggplot just basically means grammar of graphics. The idea of the grammar of graphics is that you can build nearly every graph from three basic components. First is a data set. In this case, it's one of the data frames that we've been working with and we've created. Second is a coordinate system. So we're going to need to tell it an X and a Y axis so that it knows where the things in the data set are going to be. And the third are geomes or geometries, which are the shapes that get put onto the plot in these particular coordinates and based on that data set. So these three components, the data set, the coordinate system, and the geometries are like the three essential components for visualizing information in data, from data. So ggplot2 is a library within R that allows you to create a whole variety of different plots using those three characteristics. Once we go through some of the examples in this session, it'll be really useful to take a look at the cheat sheet for ggplot, because that'll tell you kind of the breadth of all of the possible geometries and types of plots that you can create with ggplot. It's very, very flexible. It's really an amazing piece of software. ggplots are extremely customizable, so you can not only create the plot, but you can alter the colors in a very systematic and specific way that's reproducible. You can rename things, rename axes, adjust axes in a really robust way. It does take several lines of code, and we're going to dive a little bit into that. But this is kind of another one of the reasons why a lot of people use ggplot. So as I had mentioned, for almost all of the computation that you do, most of the work that you're going to be doing is in data wrangling and cleaning, because creating plots, once you have the code kind of down, can happen instantaneously. So the first thing that we need to do, and this was the point that I was alluded to earlier, how do we kind of simplify the data set so that we don't have so many columns to work with? We know that the cases per million table has 57 variables. We don't want to have to deal with all of those right now. And so the first thing that I'm gonna show us how to do is try to plot in any state that has more than 10 million, like a population more than 10 million. Let's create a line graph looking at the number of positive cases over time. So the first step to do that is, and I've written out all of the code necessary here. So we're gonna just run these things one bit at a time and see what each of them do. So here we're using a dplyr select step, similar to what we saw before. We have our pipe, we have our original data table, a new data table that we're creating. And these are the columns that we're selecting. We're selecting the date column, We're selecting the state abbreviation column and we're renaming it state. So this is one way that you can select and rename at the same time. We're selecting the cases per million, the number of positive cases, and the population in millions. This is just, I would just run this code because these are the variables that we're going to be using for today, or for this particular lesson. So if we just run that, we'll see that a new object is created, infection growth. It has 10,850 observations, similar to the COVID state data, but instead of having 56 variables, we now have 5 variables. So it's way more simplified table. It doesn't have all of the extraneous stuff that we don't need. We can actually look at it and we can see that it has the date listed, the state listed, the cases per million, positive, and population in millions. Really useful way of reordering data in a way that you want and removing anything that you don't need for your particular analysis. Following this, as I mentioned, just for this particular example, we're going to look at states that have more than 10 million, population of 10 million. So what I'm doing here is I'm taking the infection growth variable. This is a case where I'm using dplyr to overwrite or rewrite a variable here. This is like risky because, you know, once you make changes to an object, they're set. But in this case, this simplifies things nicely for us. So now we can pay attention to the number of observations and variables in infection growth. We have 10,850 and then 5. And now we're filtering only on states where pop.millions is greater than 10. So if we run that, we've now simplified our table very significantly. Infection growth, instead of having 10,850 observations, it now has 1,869 observations of 5 variables. So again, like pointing out to the fact that this is a really, really robust way of very quickly filtering, sifting through, sorting through data. And if I ever want to take a step back, recreate this infection growth table as was done originally, I could just go back to this first line of code and just rerun it, overwrite the infection growth data set again, and then we can see 10,850 observations of 5 variables. So I'm gonna just run all of these lines of code just so I can get back to that original step. So this is all dplyr commands, things that we've seen before. The next step is working in ggplot. So I've written out a relatively simple example of a ggplot command. And we're gonna spend a little bit of time unpacking how this looks. So I don't have a very, let me see if I have a strong example of how this is written. So before looking at this in particular, there's a lot of stuff in here that might not be fully clear. So for any ggplot command, the way to run a ggplot command is just by typing ggplot. And as I had mentioned earlier, in a ggplot command, you need 3 things: the data set, a coordinate system, and geometries. And so we're going to add all 3 of these components. In this case, the first thing that you list is going to be the data set that you're working with. In this case, it's infection growth. Infection growth. The next thing that you need to define is the, my internet connection is unstable. Is my audio or video breaking up to anyone?
Yeah, can you repeat what you said after you typed in ggplot?
Yes. So as I had mentioned, in the grammar of graphics, there's 3 essential components: the data set that you're working with, the coordinate system, and geometries, or the shapes that go onto the plot. So the first thing that we're going to list in the ggplot command is the data frame, or the data set that we're working with, in this case, infection growth. The next thing that we're going to define is the coordinate system. So this is written in as AES, or also, which is just an abbreviation for aesthetics. So the aesthetics are going to define this coordinate system. And you see when I type AES, the auto suggestion, it shows me this X and Y thing here. So we're going to want to plot on the x-axis the date. So this is the dependent variable, and the independent or that's the independent variable, and the dependent variable is going to be the number of positive cases. So we can, just as an example, type x equals date, the y equals positive, and this is the first two components here. This is going to be the kind of simplest version of this plot. Then what we can do is we can add a plus. So we have to add geometries to the data set plus the coordinate system. And we're going to create a line graph. And there's a lot of different geometries. In this case, I'm just going to tell you that for now, we're going to use geom smooth, which creates kind of a nice linear model based on our data. And geom smooth, the only required thing that it has, and this is just something that I'll tell you for now, but you can see the required terms by searching in the help area. So we're gonna just type in method equals auto. So in this case, it's gonna look for a method to create a linear model, and we're just gonna ask it to automatically select the linear model. And if I take this code right here and I run it, so it'll tell me, it might give me like a notification, like what kind of method it's using. And we can see here that it just creates kind of a space with one line here. And the data is not really easy to read. I don't really know what this is like. You can see that it's still numbers here. And we are looking for the population of each state more than 10 million. So it's kind of lumping all this stuff together. So this is actually a plot that we're gonna wanna work with. It's a little bit kind of messy here, or it's overly simplified, I should say. So that's just an example of running this code, and you'll see that the plot automatically appeared in the bottom right-hand corner. You can also create objects and assign objects that are plots. So in the example that I had below, I do something similar here, but I've added a couple of additional components. Before I go into these lines below, does anyone have questions about what I did in lines 623 and 624? Oh, I don't have the chat open. So yeah, the plus sign is essentially a way to pipe in ggplot. And you can add multiple layers to plots. So you can add things on like layers on top of other layers to create multiple types of plots on top of one another. The easiest way to find the available types of graph for ggplot is by looking at that ggplot cheat sheet. I often will type into Google like what type of plot I'm trying to make, and then just like in R or in ggplot. And that's like one of the easiest ways to find that. Okay, the AES section just stands for aesthetics, and that's the coordinate system where you define the X and Y variable. Yeah, thanks, Lee. Okay, so I do a couple of additional things to just clean up the plot a little bit. And so what I did in order to figure out how to do these things is I basically just searched in Google, like how to, so in this case, I wanna see a different color for every state. I don't want all of the states to be lumped into one piece. And what I found out is that I can define the color within the aesthetics. So here our aesthetics are slightly different. And all I did was add within the aesthetics color equals state. And in this case, we're going to see how this works. But in this case, color equals state is going to assign a different color to every state that exists in our table. It's not going to lump them all into one. The other thing I'm doing is I wanted to see, I don't want the date to be just listed as a number. I want the date to be listed as a date, like as something that makes sense to people when they're looking at this plot. And I can manually do it by just changing the axis legend, but another way of doing it is by using the lubridate package, which is one of the ones that I mentioned earlier. This is a good question that Deidre's asking, YMD date. YMD is a command within lubridate that tells like the parent command how to interpret the date. So in this case, YMD tells ggplot to interpret these numbers instead of as numbers, but as dates. And so, so now we're gonna, so the difference here is I just added YMD and then parentheses, I added date. And let's see what happens when we run that. Yeah, exactly. YMD is year, month, day. And there is a cheat sheet for lubridate as well. And you can see here now, all of the states have been divided up into their own lines. And it's a little bit easier to see, like, okay, this is what California looks like. This is what these different states look like. You'll notice that in the bottom right-hand corner, the image can be a little bit pixelated or like condensed. And if the window is too small, it might not even show up. This is where exporting the image might be useful. There's a bunch of different ways to do it. The easiest way is to export it and save it as an image or save it as a PDF. The PDF is useful if you're going to want to edit the image later in like a vector graphics, in like a graphics editor, like Illustrator or Inkscape, or there's a bunch of ways to edit plots like this. Or you could, yeah, just save it as an image, like a PNG file. You'll see that the menu is here. You can define the size of the plot. You can name the plot. It's a kind of a useful way of very quickly exporting items, but we don't need to do that for now. Yeah, so that is up to this point. The last thing that I'm going to show you in this is how to add labels or how to edit the what's written in the axis. Right now we have positive and YMD date on the axes, which isn't particularly informative, and there's no title to our plot either. And so in this case, you can add labels to the plot using the labs command, LABS. And you can just define the x-axis by typing in x equals, and we'll just say date here. If you put a comma and then hit return, it'll automatically indent, just like we saw in dplyr. Y equals a number of positive cases, comma, return, and then the title equals COVID cases in large states. Oops, what did I just do? States. And there's a typo in mine. So if we run this right here, we'll see now we have our labels identified and we have the plot that we've created. Now, the only difference that I have in the code that I've written over the course of this session or section was in the case below, I've assigned it to an object called plot. So if I run this code, nothing is going to happen necessarily. So I moved away from the plots tab. I'm running the code again. It doesn't automatically open up a plot until I type in plot and I run it, the object called plot. And you can see that the object gets created in the global environment. So this is useful if you want to just quickly create a variety of plots, but you don't want to see them all right away, which is something that you might want to do, like if you have a really, really large, like complex analysis that you're working with. That creates a lot of plots. Yeah.
It knew to make that line graph because of geom smooth.
That's correct.
And geom smooth just figures out the best kind of plot, or does it always look like that?
So so using a method equals auto, it will define what's the kind of the kind of equation for the linear model that that it wants to use. So in this case, it's using method LOS, which I'm actually not totally sure what kind of method that is. But I do know that if we type in LM, which is just a linear model, so y equals mx plus b model, we can see something different will appear. So I'm going to just go to this code here and I'm going to type in method equals LM. You'll see that it creates a slightly different plot, or maybe significantly different. So now it's just straight lines for everything. So one of the things that you'll learn as you start working with the different plotting packages is they come with some default settings, and they come with some required things that you need to tell it. So in this case, telling it a method is required, but you can tell it auto and it will go to the default setting, or it'll go to like the best fit in this case. But it's going to work differently for different geometries that you're going to work with, and we're going to look at one more example in a little bit. Does that answer your question?
Thank you.
Great. Do we have any other questions before we move on to the next section?
I ran the code with the title part. And I don't have any errors, but I don't see the title. Or the
did you run the code and like including this assignment operator and plot? Because there's a chance that you need to just run plot and it'll show up.
Oh, I just need to run plot? Oh,
yeah.
Okay. Yeah, there it is. Okay, thank you.
Okay, awesome. And like when I'm creating a variety of plots, like honestly, the easiest way for me is like copying and pasting code that I either written myself, or like I'll find code on other like forums that are describing how it works, and I'll edit it from there. Thanks, Lee, for that comment. LOS is a line smoothing type that shows slightly more curve versus the straight linear model. So we have a question about how do we change the format of the y-axis. So there's a variety of ways that you can change the format of the y-axis. I'll show one example. So in this case, we have a lot of very large numbers. Maybe we want to see this on a logarithmic scale. For example, and in order to do that, we can add a line. So this is something that I would look up online, but I just happen to know that in order to edit the scales on these different axes, you can use scale underscore y underscore, and in this case, we're gonna go log 10. So this is to log transform at a scale of 10 this data, which might make it easier to look at the number of positive cases. And then we're going to add that as one of the pipes or as one of the steps within our plot. So if we run this, let me see if this will work. We don't need to include anything in addition to this. This should just run by itself. And if we run that and we look at plot, you'll see that we've now log transformed the data. I don't know if this is exactly how you were referring to, but this is kind of like one example of changing the y-axis. There are like a lot of different ways that you can transform it, and in the particular way that you want, you might want to just like look it up and see what's the way to visualize it. We have another question. Is there a difference between the two codes ggplot data equals df plus aesthetics versus ggplot data equals df comma aesthetics? The first set of code in there probably will not work because the original aesthetics need to be defined within the parentheses of the original ggplot command, which is why data equals df comma aesthetics will work, but without without it will not work. If you want to view the plot as a column, I recommend looking at the ggplot cheat sheets. There's a lot of different visualization types that you can use for different things. You can create histograms, you can create bar plots in various directions. There's a lot of different ways to look at those things. Bar plots or as columns, in terms of data visualization, are not necessarily what I would personally consider a best practice, because it hides all of the data points. We're gonna look at violin plots, which show you the distribution of data in a next step, which is similar to like a bar plot, but gives you a little bit more concrete way of seeing those points. All right, I'm gonna scroll down to our next section. So we have, so let's spend the next 10 minutes or so, and I'm happy to continue answering questions about this, but let's spend the next 10 minutes or so looking at these challenges on, starting around, for me, it's line 661. It says, create an identical plot looking at cases per million, looking at cases per million for the large states instead of total cases. So here's the syntax for the code. It should be at around line 665. And basically all this is gonna change is, instead of having just the number of positive cases, we're gonna change that to cases per million. And what you're gonna have to do is fill in what the different variables are within the aesthetics for the X and Y axis. Throw up a thumbs up once you are able to get it, or a like shocked expression if you're still confused. We'll go over what it looks like for those who are having a hard time figuring it out. All right, cool. We got some people who are getting it, some other people who are stuck. It's all good. We'll go over what to do. Cool, more thumbs. Awesome, awesome, awesome. All right, so I'm glad it's working for some folks. I'll just start filling in the details just to make this work. So for YMD, remember we're specifically just looking at the date for the x-axis, date. And in this case, for the y-axis, we are gonna use CPM, cases per million. And since we're defining the color to be the states that we have here, just like this, we could just type in state. And this should work for us nicely. So first I'm gonna assign the variable CPM plot, which isn't gonna show anything immediately. And then if we run CPM plot itself, we highlight that and hit run, we can see that the plot doesn't change too much because the trajectory is it's a linear transformation. But we can see that now in our y-axis, we have cases per million, and we have these numbers change here. So now we have the cases per million values reported, and the overall cases different. So when we compare plot versus cases per million plot, we can see that different cases or different states, kind of based on the number of cases per million, their arrangement is slightly different.
Why didn't you put X equals and Y equals this time?
Great question. So you don't actually have to type in X equals or Y equals for it to know that the X and Y are being defined in that way. It assumes that X is going to be listed first and Y is going to be listed next. But if you're running into issues, I recommend typing in X equals or Y equals. So for the next thing that I want to show is there's ways to, if having all of the lines on one plot or all of these different facets on one plot is getting overwhelming, you can very easily split up plots just for visualization purposes. And so in this case, I'm gonna do something called facet wrapping. And basically that will let us define one way of separating plots into different categories. And so what I want to do for this particular case is separate so each state has its own plot instead of all being plotted on the same place. But I want to have all of the other parameters be the same. I'm just going to fill in the details here, and we can see what it's like when we separate out these facets. Yeah, date, and then CPM, state, and the rest of this should run just like it did before, highlighting the whole thing. And you can see that with just adding one line of code, I can now create 9 plots instead of one plot with all of them. And like I mentioned earlier, it does get a little bit cramped. If you export them and then open the files that are created in a new window, it will visualize a little bit nicer. I'm just gonna, for this example, change the shape of my window so you can see it a little bit better. It should automatically adjust the thing. So you can see here that it has the axis labeled equally for all of the plots. And again, you can see the dates listed on the bottom. Okay, so I'm going to shrink that down again. Okay, so that's facet wrapping, which is separating out plots based on specific characteristics. You can pick different facets depending on the different variables that you have in your data frame. But I just wanted to share this particular point with y'all before we go into the violin plots, which will be useful for us later. I see a question. What does the publish plot do? How is that different from export? That is a great question. Publish plot versus export. I don't actually see the publish plot button, but I've seen it before. Does Lee, do you know what publish plot does? Oh, this one right here. Oh, I think especially for RStudio Cloud. Sorry, Lee, were you gonna say something?
Oh no, go ahead.
I think for RStudio Cloud, it allows, so there's like a certain amount of space that they give in order to publish like documents or things that you create. I think that that's what the publish plot does. But it would like live on a live website. I'm sure there's like, checks. It won't just like publish immediately. But I think that's one option that you have in RStudio Cloud. Does that sound right, Lee?
Yeah, well, I would think that it would be for, yeah, like web, because when you hover over it, it says, can you hover over it again? It said like applications. Yeah, publish the application or document. It seems like it's more for like a HTML
Yes.
Maybe for kind of like in R Markdown when you have you can publish it as an HTML file, kind of like that.
Right. Yeah, we'll go over creating HTML files in R Markdown tomorrow, but yeah, that could be one way of doing it for sure. Okay, so it's 10:50. We're gonna create violin plots. So the last two sections are to create violin plots and to do some like very basic statistics. So let's just take a 10-minute break, regroup at 11, and then do these last two sections for the lesson for the day. So yeah, break starts now. Regroup at 11. I'm gonna hang around for like a couple minutes to answer any questions, and then I'll probably take like 5 minutes before 11.
In the console, what does that red message say? What does that mean at the bottom?
So that's a great question. So usually when you run commands, R will kind of give you one of three different things. What we're seeing right here is called a message. The message is basically like if R is making a decision. So I told it in this case, method equals auto. So I don't know what method it's going to use. And so the message that R is giving me is that the method it's using is LOS. And it's using this particular formula Y. It's like basically Y is dependent on X.
So it's telling you the assumptions that it made.
Yes. So that would be under messages. Sometimes it will give you warnings, which means the code ran, but it's giving you a warning that it might not have run exactly in the way that you wanted it to. I don't know if we're going to see examples of that until maybe tomorrow, but that is kind of one thing that you might see, and it'll say warning and then like the message. Yeah, it'll tell you in that way, a warning. And then the third would be an error or something where the code did not run.
Where's your name up? I got a warning message when I tried plotting it.
Hey, we are getting some audio. Let me see if I can see the participants panel. Why can't I see? 1 second, sorry. All right, can you repeat the question?
So I got a warning message when I plotted the part where, I did the log thing that you did.
Oh, yes, yes.
After the log thing, I got the same message that appears on your screen. But after that message, it says warning, one transformation introduced, infinite values in continuous y-axis, and then
just like this that's showing up on my screen. Yeah. So when you log transform data, if you take the log of like anything approaching 0, it goes to negative infinity. And so it's just letting you know that it's cutting off infinite values here. So it removed rows containing non-finite values. So that is what like that message would mean. So the warning messages are going to come differently depending on the code that you get. But that's one way. If you like search, if you're like looking to search how to troubleshoot, looking up like warning messages. Sometimes you'll get hints as to you know, how other people have tried to troubleshoot these different warnings.
Okay, thank you.
Awesome. Okay, so, let's see one more question. Question is, if R keeps changing the column names of the table imported, is there a way to change that specific column name? Yeah, so dplyr has a rename command that you can use. So if you are working with in dplyr, let's just kind of, I'm just going to create some space here to show an example of that. I'm assuming this is in the states column. One way to do that is we can overwrite the state pop table like this, state pop. And then we're going to use that dplyr pipe, and we'll go rename, and we're going to tell it that we want a new column called state, and we're going to give it that I dot dot state, and it's going to look for that I dot dot state, and then assign it a new name called state. But you're going to need to copy the I with the double dots directly. I don't know how to actually make it on my keyboard to copy it, because it needs to be the exact I in there. I hope that answers your question, Jinfen. The other way to do it is, the other way that you can do it is names dot state pop. So in this case, you're looking for the names of in the state pop data table, and you can tell it in brackets what column you were looking for. So in this case, we know that it's the first column. And we can use the assignment variable to force the name state, a new name, into the first column of the state pop variable names. So that is another way of correcting that I dot dot. Now, if you're trying to change the name of a different variable in your data frame, you're going to want to use the number associated with that that column name. So if we're looking at like infection growth, for example, and we want to change pop millions to just say population, we're going to want to use 1, 2, 3, 4, 5, the number 5. And that would look like this: names, section. And people don't need to do this exactly. I'm just kind of demonstrating this. Just because I don't want to mess things up for everyone else. Oops. It is infection growth. I had an error because the data frame infection does not exist. Let's see if that works. So if we look at infection growth again, and we look at our 5th column, we've now renamed it from pop.millions to population. I'm gonna change it back. Y'all don't need to worry about doing this. I just want to change it back for consistency. All right, so I'm going to take a couple of minute break, and I'll be right back. Maybe just a little bit after 11. Stop sharing for a moment. All right, I'm back. So what we covered in the previous sections, before going on to the violin plots, I'm just going to give a quick overview. We talked a lot about plotting this time. We talked about the grammar of graphics, and basically how within the grammar of graphics, you need three major components: a data set, a coordinate system, so that's the X and Y axis, and geometries, which are the shapes that get put onto a plot. And we explored creating line plots, which is the example that we see here down at the bottom, using Geom Smooth. We're going to look at another example of a type of geometry or a shape that you can create in R. And oops, I tend to forget to share my screen. So for everyone who gives me those reminders, I 100% appreciate it. So as I was saying, the three components: the data set, the coordinate system, the XY axis, and the geometries. The example that we showed was creating a line plot. We're going to look at another one soon. We can see how filtering things can be useful before plotting. And in our example plot, you start the command by creating ggplot and creating and starting with parentheses. You tell it the data frame, which is going to be the data set that you're working with. Your coordinate system is going to be defined within the AES or aesthetics parameter. You can tell it what the X and Y variables are, and you can also assign certain state or certain variables colors. And then you can add different geometries on top. In this case, we are creating a geometry, which is a line that we see in the plot that I still have open in the bottom right-hand corner. And then we can also edit certain labels to make our plots a little bit easier to read. We explored doing facet wrapping, so creating multiple plots from the same data set using this facet wrap function. We looked also at transforming our y-axes using, let me see if I can find it, this scale underscore y underscore log 10. So there's different ways that you can transform your axis. It usually starts with scale y and then some other function. You can look those up in the cheat sheet or online for additional help with how to alter axes. So the next thing that we're going to go into is creating violin plots, which are one way of looking at the distribution of data in a way that's a little bit more robust, in my opinion, than creating simple bar plots, which are really common. So for everyone who's down to move on to that next section, throw up a thumbs up, and I'll know that we can do that. Got some thumbs. We have a question: if I want to specify specific color to groups, do I assign commands in the AES or the labels? Specifying colors happens in the aesthetics. Thanks everyone for throwing up the thumbs up. Secondary question. Who has heard of violin plots before? Throw up like a thumbs up if you've heard of it, or like a shocked expression if you haven't. Oh, I love this. Hella thumbs up. A couple of shocked expressions. We'll show you what a violin plot looks like pretty soon. I'm a huge fan of them, just because I think that they're really pretty. Also, I played violin for like 10 years, so maybe that's my bias. Okay, so you know, just looking at, so I'll pull up one of our previous plots so we can just look at CPM plot facets. Oops, no, not that one. We want this one. So we can see here when we have all of the cases per million kind of all clustered all together, it's really hard to very clearly see differences in some of the recent changes in states. And we can see that like, you know, states were overlapping in certain periods of time. And we want to know, let's say, for example, you know, is one state have significantly more cases per million than another state in the last month of infections? So if we're answering the question, or if we're answering that question, we're going to want to do a couple of things. The first thing that we're going to want to do is we're going to want to take the infection growth data, and we're going to want to filter to the last month of infections. And so I happen to know that the last day of recorded data in this particular COVID data set is September 27th. So we can use the filter command to filter so that we can kind of subset our data a little bit more and visualize that last month of these large states that we're working with. So since if we look at our infection growth data, the date is written as year, month, day. So 2020, 09/27. We can filter so that any date that is greater than, let's say, August 27th, we can keep it and then just create a new data frame called last month infections, which we can use for plotting. So I'm just going to type it in here, 2020, 08, and 27. And that's going to give the last month of infections for this particular plot. And if I run that, let's see if this works actually. So we created a new object called last month infections, and we're comparing it with infection growth. So we had 1,869 observations of 5 variables, and now we have 288 observations of 5 variables. So we know that our data set was actually trimmed down in a way that we expect. And then now we're going to create a violin plot based on these cases per million. So we're going to use a very similar structure as we did last time. Since we're using the grammar of graphics, everything should be written out in a very similar way. We're going to use the ggplot command. We're going to first give it the data frame that we're looking for, so last month infections, and then we're going to assign it certain aesthetics terms. I'm going to just fill these in for you so that we can see what that's going to look like, and we'll have an opportunity to make some customizations on this plot in a little bit. In this case, our x-axis is going to be state this time. Our y-axis is going to be CPM, or cases per million. And our fill, we're going to assign a color based on the state itself. So that way we're going to get a different color for every state, just like we did last time. The command for geom for creating a violin plot is geom violin, and the required component of the geom violin is scale equals. And that basically asks like how to scale the violin. Is it going to be the area of all of the data points, or is it going to go from the top to the bottom of the plot? So in this case, we just want the area, and we can run with that now. The last bit of code here is a color customization that I've included. This basically tells it that I just want to use a range of blue colors instead of like all of the color palette that we had before. So once all those things are filled in, some people might run into errors because this requires a separate package. It's called R Color Brewer. So if you, just to make sure that it's running, so we can do library R Color Brewer, just like that. You might not see anything happen, but that's just going to make sure that the package R Color Brewer is loaded. Now I'm going to run this and see what happens. Run. And then we're going to use the CPM violin written down here to visualize it. And now what we see is we've created a plot where we create these little blobs which is showing basically the distribution of all of the data in the last 30 days or the last month or so of infections for each state. And it's assigned a color based on the state information. So go ahead and try to run that on your machines, and let me know if you run into any errors or anything that doesn't make sense. If you're able to run that and it works for you, throw up a thumbs up. So I see an error cannot add ggproto objects together. Did you forget to add this object to a ggplot object? Just check to make sure that the plus is there in the code that's written between these different items. I got some thumbs up, so it seems like this works for people. Awesome. Awesome, awesome. In our color brewer, N is too large, allowed maximum for palette blues is 9. Return the palette you asked for with that many colors. It's a good question, Patrick. Does it still create a plot or does it assign different colors to your plot? I haven't seen that error before. If you want to do it, so if you're having issues with our color brewer, you can test to see if it'll still create a plot without that particular line. So if I just delete that line, oops, I'm gonna just cut it so that I can save it. And I run this code, it'll still assign colors based on the state, but it's gonna use its automatic color palette. So it'll look like the colors that we had earlier. Oh, right. Yeah. So if you have, I see. Okay. I don't know. It sounds like you figured out your issue. So in that case, you're going to want to filter again for the large states. I'm going to run this again just because I like those blues. It's a nice range. All right. So as a lot of people who have done any sort of data analyses before, especially when you're looking at like bodies of data associated with particular categories like these states, you rarely create plots without your error bars, your mean and standard deviation. So I'm going to give you a line of code that'll allow you to create a mean and standard deviation line that'll sit on top of the violin plots that we just created. Around line 709, we'll see something called CPM violin 2. And we have a bunch of things that you can fill in here. Go ahead and fill in the different aesthetics. This should look exactly like what we did before, but there's going to be this additional line here that says stat_summary. So go ahead and fill these things in. And try to run this a bit of code and throw up a thumbs up if it once it works. I'll explain the stat summary in just 1 minute once we kind of create the plots. Interesting. Does anyone else get the same error for stat summary? This worked for me like yesterday. Wow, people get the same error.
Got that too, Eves.
Oh, this makes me not less than excited. So it says HMISC or package is required for this function. So if this is the package that it's asking for, we can try install. Oh, someone says they installed HMISC and it worked. So let's go install packages and type in. So it'll probably take a second to install. So you will run into errors like this at times where people, like, for example, if you look up code to see like how to do something in particular, and they ask for a command that you don't have installed, usually R will tell you, like, it either can't find the command, and you'll have to search for what package to install, or it'll just directly tell you what package to install. So for me, it's installed. I can use the library command to load it. It might give me some errors, some things. And then let's see if that works for us now. Great. So it's a little bit crowded, but we can now see that the standard deviation bars were included. The standard deviation bars were included. It's difficult to see with this particular color palette. There's a lot of different color palettes that you can use. If you just search for like color palettes in R, you can find out what the different ones are. Question, what does scale equals area mean? So let's take a look at the help area, violin, and see if it gives us any additional information. I'm not 100% sure if that will. Well, let's see. So scale, so it tells you scale equals area. And we can look at the arguments here, and we can scroll down to where it says scale. So the area is default, which means all the violin plots have the same area before trimming the tails. So if you have scale equals count, the area for the violin plot will be scaled proportionally to the number of observations. So if you have more observations in one variable as compared to another, let's say you have 30 observations for one state, but they only measured, once a week for other states. So you have 4 observations there. Then it'll create a violin plot that's scaled based on the number of observations that you have. And if it's scaled by width, then all the violins plot will have the same maximum width. So we have an error, package or namespace load failed for HMISC. In this error, there's no package called Grid Extra. Jensen, are you working in on your local machine, or are you working on RStudio Cloud?
No, the cloud.
In the cloud, interesting. I might need to get back to you on how on this. I'm not sure why this isn't working for you. Maybe Lee or Jamie, you can kind of look into some of the background on that. Okay, we have a couple of people who are having the same issue. So I'm going to really quickly explain what this stat summary function does for those of you where it's working. And hopefully we can get that issue ironed out before. Yeah, typing in the command that you entered before you receive the error is very helpful. So for the stat summary function, it has 2 kind of like required components. This, so we can look it up actually here, stat summary. And it'll tell you some additional stuff about it. The fun.data argument is a function given the complete data and should return. So this isn't super informative. Unfortunately, the stat summary function is kind of a little bit opaque, but basically it's asking for what do you want to summarize the data? And there is, I actually looked up this code to see how other people created means and standard deviation. And if you just type in mean _ SDL, that'll give it a mean and a standard deviation line. And then based on what you put in under fun.data, you can tell it, you can add this additional argument, which shows you how many standard deviations you show in that line. So this list mult equals 1, mult just means multiplier, and the 1 is the number of standard deviations here. So we're showing plus or minus 1 standard deviation. If we change this to 2, it'll add 2 standard deviations to the line that's getting added to the plot. I hope that's helpful. There's like a handful of ways of putting mean and standard deviation lines into plots, but this is one of the ones that I use relatively frequently, and I honestly usually just copy and paste it. And you can see here that stat summary is added as one of those like plus things within the ggplot command. Cool. So so the last thing that we have in the for today is doing some basic stats. Let's spend maybe before we get into that, let's spend maybe the next 8 minutes or so just taking a look at this section that says reflections and connections, where you can get a chance to look into the documentation for Geom Smooth, look at the different methods, parameters. You can even copy and paste the code and try to mess with it a little bit. Look into the documentation for Geom Violin, see what other parameters are that you can change. And if you don't want to do those, just take a quick look at the ggplot2 and see if there's a way to add a dot plot or something on top of the violin plot. I'll give like maybe 10 minutes or so to do that at 11:33 or maybe 11:35. I'll go over the last bit of doing t-testing with our data set. And I'm happy to answer any questions that come up over the process.
I've been using the desktop RStudio because I'm running into a problem with RStudio. I get these internal server errors when I try to create a new project. I don't know if there's too many people on there or what. So I couldn't reproduce the error that somebody was having earlier.
Mm-hmm.
Is there a limit how many people can be on RStudio with our UCLA account? I mean,
I think since everyone's using their own email address, there shouldn't be any limits. I'm not sure if it'll like automatically impose limits for institutions. I know that you know, I'm sure they run into various stability issues, but I didn't see any notifications about stability errors in RStudio Cloud.
Okay. Maybe it's just something with mine.
Brian, the question about installing H miscellaneous, you should just be able to type in install packages and in quotations HMISC, and that should work in it. I see the grid extra package. I see. In that case, what I might recommend is for those of you having errors with installing these pieces, go into your packages tab and uncheck the different packages that we loaded, and recheck them in this order. Maybe it might be that that certain functions are masked because of the order in which packages are loaded. So if you load them back in this order, I'm typing it into the chat. I think that should work. So we're first load dplyr, then ggplot, then lubridate, then rcolor brewer. And then try to run it again. So when people see the following objects are masked from, that's when you install something and it kind of like prioritizes the command from that particular package over others. It could be that that just the order in which you load packages leads to this error. And then if you're still so I guess detach all the packages and then try to install H miscellaneous or HMISC. I've never seen this error before. Jamie, for the server error, I'm not really sure how, because it seems like you ran into this yesterday as well.
I logged out and I logged back in, so now I'm creating a project. I'm just gonna try to go through it and get that error, get the same error somebody mentioned earlier.
I see.
Okay.
Okay.
Yeah, that's weird. I don't know why I got the. I think sometimes re-logging in or logging out and just kind of like burping it.
Yeah. It's a great analogy.
Yeah. Copy the link. Okay, so I can do this.
So just going over some of the questions here. We can look into the documentation for GM Smooth. The method parameter, as we talked about a little bit earlier, defines how that model is fit based on the data that you have. And we looked at using low S versus linear model versus auto, and changing the method parameter just defines how that curve is created. So for the GM violin, the scale parameter, we did talk about that a little bit earlier. It is just covering the shape of the size of the violin that's created on the plot relative to the other ones. And we saw a couple of different examples of that. The text wrap, yeah, that's a good question. In order to do the text wrap, we covered that right at the beginning on the first day. But if you go under the tools area and you go into global options, under the code section, you can see soft wrap R source files in here. If that box is checked, then your text should wrap. And then if you scroll down and hit OK, it should work. All right, so if we wanted to add a dot plot on top of the violin plot, how would we do it? So I'll just copy and paste our violin plot from earlier. I don't know if this is gonna look particularly pretty, but if you have few enough data points and you wanna see all of the points that are associated with your graph, you can add the dot plot on top of your violin plot. In this case, since people were having some issues with the stat summary, I'm just gonna remove this particular line and it should still work.
I can move over that way.
We're getting some audio from someone. I'm just gonna mute you. Okay. So if you wanna add a dot plot, I'm gonna pull up my handy dandy. I happen to have a copy of the cheat sheets in physical form. I'm just gonna look it up. I think it's geom point. Nope, it's geom dot plot. So geom dot plot, oops. And let's see if it requires any particular aesthetic. So I'm just gonna run it like this and see if it asks for anything in particular. So it requires the following missing aesthetics. So let's see what geom.plot help wants us to do. Geom.plot. Give it a second to load. And we can just look at some example usage here. So it wants some additional information. There's a bunch of different examples. I think the all we need is this stack direction in here. So stack dir equals, we'll add center. This is just coming from experience, but in the cheat sheet, if you see geom.plot, you'll see how they ask you to add certain features. So we can add bin axis because we wanted to know which axis to create bins. Y, and then stack direction is center. Hopefully this works. Let's run it and see what happens. Oops. So it's not a particularly pretty plot, and the points cover the violin plots, but now we can see that all of the points have been added on top of this layer. So you can see that there's a lot of ways to visualize different things. You can add layers on top of other layers. This may not be exactly the best example for putting dot plots on there, so I apologize for that. But this is one way to create these dot plots. Just go back to the one that worked earlier. Sorry, I'm just loading the CPM violin 2 that we did earlier. So we have object violin width not found. Best way to troubleshoot that is showing the code that you typed in. You might want to set the scale within your geom violin to something that it'll recognize. In this case, it will be in quotes area. So here you have scale equals auto, and it doesn't have an automatic, like a default setting. You want to use area. Awesome. And you'll see by adding a geom dot plot, it's like just adds a whole bunch of dots on there. There's ways to change the size of the dots and other types of customizations. If you're trying to create a dot plot, you can feel free to look up various resources online that exist. So I'm going to move on and really quickly cover performing basic stats, the performing basic stats section. So we've gotten a taste of what R can do in data visualization. We have plots, we can see the mean values, standard deviations. Again, as I mentioned before, a lot of times we're trying to do some sort of statistical testing, comparing different populations to see if there are significant differences between different populations. In a very, very quick example that I'm going to show in the last 10 minutes here, we can compare to see. So if we look at our plot right here, it's pretty clear that California and Florida, for example, are quite different from one another. But we can perform a t-test based on the 30 days of the data that we have to see if they are significantly different as based on this t-test. Basically, our null hypothesis being they have the same number of cases per million in the last 30 days. So I'm going to create two new data frames based on our last month infections data table. And I'm just going to be using a simple filtering step where I'm only pulling from specific states. So I'm creating a new object called California cases, and I'm filtering the state equals California. I'll just run that. You can see that object gets created. It's 32 observations of 5 variables. And we can do the same thing for Florida cases, and we can see the same thing, 32 cases for 5 variables. And you can see if we click on those tables, that only the cases for those particular states are included. Same thing for California here. And all we really need to do using the t-test function is, in order to compare these columns within these two tables, is you can use the syntax right here. So just typing it out, you can use t.test, which is the basic function for t-testing. You tell it what data frame to look in, California cases, and then tell it the $ and pick the column that you want to compare. So this is going to be the first list that it compares, and the second list, Florida cases, $CPM. It's the second that it compares. You can highlight that and you run, and it conducts a basic Welch 2-sample t-test. And to read this, it creates a t-value, which is basically the value that's produced from the statistical test, the number of degrees of freedom, and the p-value. So this is going to be what a lot of people are looking for, is a p-value. And in this case, our p-value is very, very small, 2.2 times 10 to the negative 16. And the alternative, so this means that our alternative hypothesis is true, that the true difference in means is not equal to 0. So what that means is that they actually have different means. It gives us a confidence interval, and it gives us estimates of of these two, the averages of the cases per million for each of these states. As I mentioned earlier, Florida and California are qualitatively very different. Even just on our plot, we can see that they're like very far apart. We can also do this test for states that are more similar. So we can't see the difference between between Ohio and Pennsylvania here. And so we can use the same approach to see if they're significantly different. So I've just copied over some code for this, and you can fill in the blanks or the X's to get it to run properly. So this is in line 786 or so. So go ahead and do that, and let me know if it works. What did you, and write in what you get for the p-value into like the chat. And I think we'll leave space for questions and any points of clarification about anything in the statistics section. There's a lot of different statistical tests that you can do in R. Once your data is in a data frame or in a list that you want to work with, you can, I generally look up online what's the statistical test that I would like to do if you happen to know which one is appropriate for your particular analysis. And then most people have like instructions as to how to run those tests.
Yeah. I don't know if it's just something. All right, I can do it then. So what are we looking at? We're looking at...
Does someone have a question? We have someone unmuted.
Oh, sorry, that's me.
That's okay. So once you have a p-value for those last couple of lines of code, throw in the p-value that you get for this particular section. Oh, someone dropped in what they got. Interesting. I did not get 2.2 times 10 to the negative 16. Let's see, let's type in t.test. Oh, that's why, because I forgot to change the state things here. So if you got 2.2 times 10 to the negative 16, it's because you forgot to change the state to match the correct state. So we're looking at Ohio in this case and Illinois in this case, IL. Test. And it should be, oops, my bad. We are filtering here. Filter, state equals California. Filter, state equals Illinois. We can run these. It'll do the filtering step. And then t.test. OH cases, CPM, IL cases, CPM. You run that.
Sorry, in Ohio, then you have filtered California.
Thank you. I was like, that's not right either. So this is when you want to double check to make sure all the filtering and everything that you've done is correct. And that is definitely helpful. Yes, I'm getting something different.
I think it's just by chance that the p-value is the same because the means are different and like T is different. Oh, it's just that by chance that it's 2.2, same as California.
Sorry, everyone. I'm like picking random variables. I'm not actually doing the test that I've asked. So it's Ohio versus Pennsylvania. Oh my goodness. There we go. 0.0319. I appreciate everyone's patience. Yeah, now you can get it to work. So this is how you do a basic t-test using the R's base package. Thanks everyone for that. So I'm gonna stick around and answer any additional questions. I'll just in closing, I'm gonna send a follow-up email a little bit later today. This concludes what we're gonna do with part 1. And tomorrow I'm gonna have a new set of data for everyone to download. So I'll send it to the helpers and we'll add it to the box folder and whatnot. I'll send an email with instructions as to how to open all that stuff. We're gonna move on to the next part of this lesson, where we're going to look at our markdown documents, which is basically a format of using R where you can create reports and embed R code into HTML documents or PDF documents or Word documents. R Markdown is a really, really useful and robust platform. So we're going to learn a little bit about that, and within there's going to be instructions for the people who are taking 275 and 199, instructions for the assignment and quiz for today. For everyone else who is in the class, the assignment is going to be optional, but we're going to work on it partially in class to get a little bit of experience. Tomorrow is going to be also the main day where we have breakout rooms. I'm going to divide everyone up into rooms to have a little bit of chance to create their own plots and customization. So if you have time between today and tomorrow, I recommend just quickly reviewing the ggplot cheat sheet and try to contextualize it based on the material that we covered today. Reviewing the dplyr cheat sheet to see what kind of options for filtering you have, and maybe looking at some of the data tables that we've created over the course of today to see how would you want to visualize these different data types. I may have had in the outline that we were covering heat maps. Unfortunately, I decided I wanted to show some other plots, and we are not going to be covering heat maps in the session today. However, if you follow up with me over email, I have kind of like a side, like a little resource that will make it useful for you to learn plotting with heat maps using the exact same course materials that we have for today. So just follow up with me if you're trying to learn heat maps, and I can help you out. All right, so with that, that is the end of our session for today. Feel free to sign off. Thank you for everyone's participation. I hope everything was clear. Look out for that follow-up email. The recording is going to get posted into the box folder shortly afterwards. It usually takes about an hour to load. Thanks again, everyone, for your participation. If you have questions, you can feel free to stick around. I'm going to be here until noon to answer any additional questions.
Finally got, I finally got this loaded into RCloud Studio, so I'll have that at least for tomorrow. If someone's got a question about that.
All right,
I don't know why I was getting some kind of internal server error, but I logged out, logged back in. Yeah. I'm just not used to using it. I'm used to using the desktop, but I figured I'll have it on hand.
Right. Yeah, I appreciate that.
That's okay. I should get used to how do you use this.
I know the cloud is like, I find it to be super, super useful, especially when I run into errors like on my desktop app. I generally go to the cloud to see like, will this run in the cloud? And like often, like it'll run perfectly in the cloud. I don't know why. So I like teaching with the cloud because it generally has fewer errors, but clearly people did run into errors.
Well,
oh, sorry, go ahead, Jamie.
Oh, I was just gonna say it's handy because then sometimes we've had problems getting it installed, so you kind of save some time on the install issues.
Mm-hmm. Yeah.
Hey, I just wanted to bring up, so I was helping Roy, who had a very specific issue when we were doing violin plots. So I was wondering if either of you could help troubleshoot that too, because we weren't able to figure it out.
What was the issue?
So, hold on, I'm getting a new message.
Okay. Oh, I'm gonna stop sharing. I'm gonna stop sharing and stop the recording for now.